continued before?
We'll try to finish today for another 30 to 45 minutes.
Now, how long you have you know you have taken before?
It is around 45 minutes. 45.
Okay,
Yeah.
but it was said at 8 o'clock, isn't it?
Yeah, because initially we had some problem joining the link, so that is where 10 minutes it got delayed.
Uh, but what time is it now back there?
It is around 9:20 p.m.
9:20. Oh, yeah, okay, got it. Yeah.
Fine. So we now have a basic understanding of the HTTP protocol. In HTTP request and response, we have there are different HTTP methods which you will get whenever you are trying to investigate or inspect the application traffic. Like for example, get, post, head, put, delete, options. So these are basically different kind of methods on how you are trying to fetch the remote resource on the remote server. And as per these requests, there is a response which comes back from the remote server. So those are basically represented by your HTTP codes. There are basically 5 series of codes: 100, 200, 300, 400, and 500 series. 100 basically represents 100 basically represents informational request. 200 represents successful, that the request is successful. 300 denotes redirection. 400 is client side error, and 500 is server side error. So now that we have a complete overview understanding of the application traffic flow and basic of HTTP, let us dive into understanding load balancing. When we talk about load balancing, let's assume that this is the user who's connected to internet, and then he's trying to reach out to a web server. This web server might at the backend be communicating to a database server. So this is a specific infra where there is no load balancing. Now, the question comes is, what exactly is load balancing? So basically, load balancing is the entire intent of virtualizing the service which is present on this server. So basically, let us assume I have this web server with this IP address and it is listening on port 80. So what I'm doing is, instead of this one IP address, there might be different multiple web server 2, 1, like web server 3. So instead of all these IP addresses, what I'm doing is I'm trying to virtualize this service and have one single representation, IP address and port. So a more basic definition is to balance the load across a physical bunch of servers and make those servers look like one big server to the outside world. So to outside world, it is only just one IP address, but at this IP address might be configured on your load balancer, and at the backend from in here, the traffic is being sent to different web servers, be it web server 1, web server 2, or web server 3. Now the primary drivers of this load balancing are: first is scalability, next is high availability, and third is predictability. So when I talk about these different terms, let's try to understand what all these terms actually mean. So when I say scalable, let me think it from a server admin perspective. Okay, let us say that I have one IBM server which has 2 CPU cores and let's say 120 GB RAM, 4 TB hard disk. This has some limited resources, and I being a developer, I have designed an e-commerce website. For example, www.test-corp.com. This is my e-commerce website which I have launched, wherein I am selling multiple different products. So after designing this application, I go and tell my friend, hey buddy, why don't you try out this specific website? I have designed it newly. So on day one, let's say I just tell my friend Ram about this. He might use this application and he might tell three more people. These people also try to access this application. They also like the whole overview of overall concept of this specific application, and they also try to advertise it, and they tell maybe 10 more people, then again 100 more people. So likewise, from day one, let's say down the lane, 90 more people know about it. The traffic which is being generated from different user machines towards this server keep on increasing. So at the end, what happens is, initially, let's say on day one, only 10 requests basically were hitting the server per second. This server has a maximum capability of handling 1 million requests per second. Down the lane, 6 months, amount of traffic which started hitting this specific server started increasing. The traffic increase basically resulted in decrease of the performance. So basically on day one, the server was totally free. It was serving all these requests, processing all the requests which were coming at a faster rate. The more overloaded the server became, at the end, the performance of this application was impacted. That is wherein the server admin guy decided that, okay, now it is time that we introduce another server. So let's say this is server 1. We introduce server 2 as well. Now that I have introduced these two servers, let's say assume that the IP address of this is 172.16.1.1, listening on port 80. This is 172.16.1.2, listening on port 80. And both are hosting my application test-corp.com. Now the question is, how do I actually send the traffic to both these servers? Sometimes to this, sometimes to this, so that the resources of both are being utilized, and at the end, from a client perspective, the performance is not getting impacted. So in the initial days, what used to happen is this was being achieved by DNS. So basically what was done is, on the DNS server, there were two records which was created. 172.16.1.1, 172.16.1.2. Whenever a DNS query was initiated to the DNS server, the DNS server responded back these two IP addresses in a round robin fashion. So sometimes the user got connected to this server, sometimes it got connected to this server. This was back in 90s. Long time back, this was the solution which was used to achieve load balancing. But this was not efficient in the term that, let us assume that at some point of time, this server is down for some reason. Or maybe this specific service on this server is in hung state. And that time the DNS server responded with this IP address. So what client will do is, client will try to establish a connection to this server, and at the end the website will not load up. So basically this specific solution was not effective. So scalability, whenever I say scalability, it means that the capability of adding up or dynamically increasing, adapting to the increased load without any impact in the existing performance. So let us assume that instead of this DNS server, we add up a load balancing solution. So basically our traffic will hit to this load balancer. From here, it will be decided that traffic should go to which server. My intent of adding up more servers should be completely transparent to user. It should not impact in any terms. So I can basically add up these servers as per my increased load without any existing performance impact. This was about scalability. Now, next thing which comes into picture is high availability. In today's world, any application you take, specifically a banking website, can you imagine the kind of impact it can bring to a banking website if that website even goes down for 5 minutes or even for 1 minute during production hours? No, it will bring a huge impact. You as a customer, you only think that, let us say you have accounts in different banks. Whichever bank is giving you a better service in terms of ease and have a good performance of their internet application, you will be trying to prefer that. There is a zero tolerance of downtime which can be accepted from a user perspective. One of the driving factors of load balancing is to make sure that your application is basically available all the time. So in order to make sure this that the application is available all the time, what load balancer will do is it will try to perform the health check of these remote servers which are configured behind the load balancer in a frequent interval. So HA basically is the capability of the site to remain available and accessible even when one of the service goes down or there is failure with one or more service. These two servers going down will not bring any impact to the user because the user's traffic will be going to other servers which are configured behind this IP address. So basically, the scalability and high availability, both these result in predictability. Predictability can be described basically as the capability of having the confidence and control in how your services are being delivered with regards to application, availability, performance, and so on. So when we talk about any load balancer, F5, if you consider as a vendor, there are multiple vendors when you talk about load balancer. Citrix, Netscaler is there, Microsoft load balancer is there, Cisco load balancer is there. So F5 basically has designed not only a load balancer which loads sends the request to different servers, but it does a lot more than that. So during this course, throughout this course, we'll be saying what are the various functionalities which this F5 delivers. So basically a solution which controls this traffic flow is something called as application delivery controller. Application delivery controller basically manages how your applications are being delivered. Whether at the backend there are 2 servers, there are 5 servers, what should be the load balancing method, how your requests are being delivered. It has the basic capability to direct or redirect requests to appropriate resources. So for example, let's say you have different servers. This server is basically optimized for Android users. This server is optimized for iPhone, Apple users. This server is for general other users. So now my requirement is I want to make sure that when any traffic hits my load balancer, if a user who is requesting from Apple or is using from Android phone, my request should be directed towards the server, which is optimized basically for that purpose. Then load balancer can also intercept, inspect, transform the requests which are flowing through it. In here, for example, this side, a request came in as get index.html. So this side, the load balancer can maybe send a modified request as get, let's say, hello dash index.html. So basically, this server team has designed the application in such a way that it does not want the end user to type this hello, or this hello should not be visible. This hello is basically a directory on the web server which should not be visible to the client. So client should only be accessing for something like, let's say, app.com slash index.html, and this should get. But whenever this request is generated from the client machine towards the load balancer, the request which actually goes out to the server is get / hello / index.html. Then your ADC also has a capability to verify the health of server, because there is no meaning of sending the application traffic to a server which is actually down. So your load balancer needs to make sure that the request which is going to the remote server is in a healthy state. So it, on a periodic basis, it performs the health check of the backend servers. And only when it finds that the server is in healthy state, it then sends the application traffic towards it.
Vineet?
Yes.
Sorry to interrupt. I think this the meeting will get disconnected in another 1 minute or so. So I'm just seeing remaining meeting time there. So yeah, I think that's because it's 40 minutes, and then I think we started late, right? So
Mm.
so just had a query before it gets cut. Just want to know if you will be sending us the PDF and the recording to our email ID.
This recording, I'll check with the team, and probably they will share it with you.
Okay, and how about the PDF?
As long as PDF is required, I can only give you the certification guides, which are available on internet. I will share the link with you, and
Okay.
this course is totally designed in terms of, I'll be giving the running notes. If you have any specific doubts, you can ask me then and there itself. If there is something that I'm not able to clear, I'll try to give you any examples. And basically, we'll first try to understand the concepts and then implement it on F5. We'll try to build the box from scratch, how when a new box comes in, how you configure it, and from there in we'll see each and every parameters. And at the end of this course, I will be basically giving you a specific set of tasks which you can build your own lab and practice it on your